All right, let's talk about a tool that on the surface seems pretty simple, but is actually packed with some seriously clever engineering and a ton of surprising uses. We're diving into the heat gun.
Okay, so let's just jump right in. Because when you first see a heat gun, it's easy to just write it off as, a super-powered hairdryer. But what it can actually do, yeah, it's pretty mind-blowing. So to get us started, let me just ask you this. What on earth could possibly connect stripping paint off an old dresser, popping a dent out of a car bumper, and yes, even getting your barbecue lit on a weekend? The answer, you guessed it, is the heat gun. And what's really wild here is the sheer range of jobs. We're not just talking about brute force heat, right? This isn't some blunt instrument. It's a precision tool. I mean, you can go from gently thawing a frozen pipe without a dangerous open flame to carefully shrink-wrapping some delicate electrical wires. The versatility is just incredible. So what exactly is this thing? Well, at its core, it's an electric tool that shoots out a really powerful, really directed stream of hot air. Yeah, it looks like a hairdryer, but the real difference, the game changer, is the power and the temperature. And this number, wow, this puts it all into perspective. 600 degrees Celsius. We're talking about temperatures that are hot enough to soften some metals, to strip layers of old, stubborn paint in seconds. Your hairdryer doesn't even come close to that, not even in the same league. So how does this kind of simple-looking tool generate that much intense heat? Let's pop the hood and take a look at what's going on inside. On the surface, the inside is incredibly straightforward. You've got a motor. That motor spins a fan. And then you have a heating element. That's pretty much it. Just 3 main parts doing all the heavy lifting. And the process itself is just this simple, elegant sequence. The fan sucks in cool air from the back. It gets forced across that red-hot heating element. And then, bam, superheated air blasts out the front nozzle. Simple, but oh so effective. Oh, and here's a quick pro tip for any first-time users. If you plug in your brand new heat gun and you see a little bit of smoke come out for the first, say, 20 seconds, don't panic. It's totally normal. It's just a protective coating on the heating element burning off. But this is where that simple design starts to get really, really cool. It's hiding some very clever science and some slick engineering choices, especially when you look at the real heart of the tool. So that heating element, the heart of the tool, it isn't just a simple wire. You've basically got 2 main types, mica and ceramic. And as you can see, the ceramic element is a huge upgrade. It gets hotter, it's way more durable, and it gives you a much more even, uniform heat. Sure, it might cost a bit more upfront, but it absolutely makes for a more capable and longer-lasting tool. Of course, with all that crazy heat, you need a fail-safe, right? Well, every heat gun has this vital safety feature called a thermal fuse. If the tool starts to get dangerously hot, it cuts the power to stop it from getting damaged or, catching fire. But how it does this, well, that's just a stroke of genius. Okay, get this. This is so cool. When that fuse trips, the tool doesn't just shut down. It actually rewires itself on the fly. It reroutes the circuit to connect the fan motor directly to the main power source. This makes the fan spin insanely fast, aggressively cooling down that heating element until it's safe again. The failure state actively saves the tool from destroying itself. It's just fantastic engineering. So, hey, it's no surprise that researchers at MIT came to this conclusion. What looks like a really simple tool is actually this complex dance between electrical, mechanical, thermal, and fluid dynamics, all happening inside that little plastic shell in your hand. All right, so now that we've properly geeked out on the science, let's get practical. If you've decided, hey, I need one of these in my life, what should you actually look for when you're buying one? Now, you can look at wattage and airflow, and they're definitely important. But the single most important feature, the one that gives you all that versatility, it's variable temperature control. The ability to dial in a specific heat is what separates a basic paint stripper from a precision instrument you can use for molding plastics or working on electronics. It's a must-have. And the attachments. These little nozzles are what truly unlock all those different uses we saw earlier. A reducer nozzle lets you pinpoint heat on a single rusted bolt, while a diffuser spreads it out for stripping a whole door. The right nozzle really does make all the difference. But what happens when this complex little machine finally gives up the ghost? Is it just another piece of e-waste that's destined for the landfill? Well, let's look at a pretty common real-world scenario. This is a story I think a lot of us can relate to. Posted over on Reddit. You're right in the middle of a project and poof, the tool just dies. No heat, no fan, nothing. So, what's the likely culprit?
Well, it could be a few things, right? That thermal fuse we talked about, maybe a bad power switch, a fried motor. But surprisingly often, the problem is much, much simpler than all that.
And the solution is right here in the user's update. After checking all the complicated stuff, turns out the problem was just a simple break in the heating element's coil. A quick reconnection, a fix that cost absolutely nothing but a few minutes of time, and the tool was back, good as new.
And this kind of leaves us with a final thought, doesn't it? In an age where so many of our devices are just these sealed black boxes, there's something really remarkable about a tool that, despite its hidden complexities, can often be understood and repaired with just a little bit of patience. It makes you think about what we really value in the things we own. Thanks for tuning in.
Hey, welcome to The Explainer. This is where we take a look at the fascinating things all around us and, well, we break them down.
Okay, so what do you think? You're probably picturing, a whole bunch of different tools, right? One for each job. But what if I told you the answer is actually a single, really versatile device?
Yep, the heat gun. And I know what you're thinking. It just looks like a hairdryer on steroids. But trust me, it is so much more than that. It's one of those tools that's absolutely essential for tons of DIY tasks, everything from big home repairs to even crafting.
All right, so let's just jump right in. To really get a feel for this thing, let's look at the huge range of stuff it can actually do. It's pretty wild.
I mean, look at this list. It is all over the place. One minute, you could be hunched over a workbench doing super delicate electronics work, soldering tiny little circuits. And then, the very next minute, you could be outside using that same tool to free up a massive rusted-on bolt. Or, get this, even repairing a car bumper. The sheer range is just wow.
So yeah, it's definitely not your average hairdryer. And the real difference, the thing that sets it worlds apart, it all boils down to one simple and honestly kind of scary number. 600 degrees Celsius. That is over 1,100 degrees Fahrenheit. We're talking hot enough to actually soften metal. And that is exactly why you really, really need to understand how this thing works before you just go and pick one up. So, what's the secret? How does this thing, which looks so simple on the outside, create that kind of intense, focused heat? Well, the engineering's actually super clever, but also really straightforward. Okay, so at its core, it's basically a three-part system. You've got a motor and a fan that pull in regular room temperature air, then that air gets blasted through a super hot heating element, and finally, a nozzle focuses all that hot air into a powerful stream. Seems simple enough, right? But the magic is really in the details.
Let's talk about that magic component, the heating element. Because this is where things get interesting. See, not all of them are built the same. And this is really where you can tell the difference between a cheap, budget tool and a high-quality, pro-level one.
So on the cheaper end, you'll often find these thin, kind of fragile sheets of a mineral called mica. They wrap the heating wire around it, and, it works, but it's not super durable and it can't get quite as hot. But the better guns, they use a solid ceramic core. Think of it like a piece of pottery. It's way more robust, it can handle way higher temperatures, and it just means the tool is going to last a whole lot longer.
Okay, so a tool that gets hot enough to melt metal, doesn't it run the risk of, melting itself? It's a fair question, but the engineers thought of that, and they built in this really, really clever little safety feature to keep it from literally destroying itself.
It's this thing called a thermal fuse. And here's the brilliant part. When things get dangerously hot, the fuse trips. But it doesn't just cut the power off. Now, that's too simple. Instead, it reroutes the power to make the fan go into hyperdrive. So it starts blasting the super hot element with cool air until the temperature drops back to a safe level. It literally uses the overheating problem to power its own solution. How cool is that?
Okay, so now that we know what's going on inside, let's bring it back to the real world. How does this help you choose the right heat gun? Because, well, knowing what's under the hood definitely helps you know what to look for on the box.
Look, the most important thing is to match the features of the gun to the job you're actually going to do, right? So if you're going to be working with delicate plastics that could melt easily, you absolutely need precise temperature control, probably with a digital display. But if you're stripping paint off a huge door, you'll care more about different airflow speeds and having the right kind of nozzle. Getting the right features just makes the whole job safer and a heck of a lot easier.
All right, you've got your gun, now what? Well, the good news is, using it right is actually pretty simple. It really just comes down to a couple of key things: control and paying close attention to what's happening.
So let's take maybe the most common use for a heat gun, stripping old paint. Here's the #1 rule. Keep it moving. You have to be in constant motion. Don't just hold it at one spot, because you're not trying to scorch the wood underneath. Your goal is just to heat the paint until you see it start to bubble and wrinkle. The second you see that happen, that's your cue. Move the gun and get your scraper in there.
We've all been there. You're right in the middle of a project, you're in the zone, and then, poof, your tool just dies. It's super frustrating, right? But with a heat gun, a lot of the time, it's actually a pretty simple fix.
So this exact thing happened to a Reddit user named Embigo over on the electronics repair subreddit. They posted that their heat gun just stopped working. No heat, no fan, nothing. And of course, the community was right there to help them troubleshoot.
So, what were the usual suspects? Well, first up was that clever thermal fuse we just learned about. It could have tripped, or maybe it was just a bad power switch. But another really common one is a simple physical break in the heating coil itself, that little wire that gets super hot.
And sure enough, Embigo took the advice, opened up the gun, and found the problem. It wasn't some complicated electronic burnout. It was just a little break in the heating coil. They called it the resistor in their post. All they had to do was reconnect the two broken ends of the wire, and boom, the heat gun was back in business. And, this whole story, the sheer power of the tool and the fact that you can open it up and fix it, it all points to the single most important thing we need to talk about, safety. When you're dealing with this level of heat, you have to take it seriously. Okay, these rules right here, they're not just suggestions. They're non-negotiable. You are literally holding a tool that can cause serious burns or start a fire in a split second. So always, always wear your gear. Oh, and a quick heads up. When you first use a brand new gun, it might smoke for like 30 seconds. Don't panic. That's just a protective coating burning off the new heating element. It's totally normal. Just remember to let it cool down all the way before you store it, and you'll be good to go. When you think about it, the heat gun is just a perfect example of how much amazing science is hiding inside the simple tools we use every day. It's this beautiful mix of electrical, thermal, and fluid physics all working together. And it's a great reminder to stay curious, to look a little closer at the things around us and just appreciate the brilliant engineering that makes them possible.